So in this video, we will cover what is WebRTC, what are the advantages to use the WebRTC. So basically WebRTC is so if we go to the official Mozilla documentation for the WebRTC. So what is WebRTC? WebRTC is a web real-time communication. It's a technology that enables the web application and the site to capture or optionally send the streams, audio and video without requiring any intermediary. So what does it mean? We don't need to send the data to our server and then client 2. So WebRTC is basically for the web applications. It support Android, iOS, browsers. So it's basically a inbuilt JavaScript technology. So we can use to pass the data. Inside data we can send like chatting, we can use in the real-time chatting, real-time broadcasting, video app, audio app, etc. So WebRTC is related to web, and Android and iOS are also supported it. So what's the, if we want to send a data from client 1 to client 2, so generally what happen, first we will send some data to our server and server passes this data to client 2, and same for if something sent from client 2, then server will send to the same data to client 1. So what's the problem here in this scenario? Server is using server basically uses to pass the data without change anything. So there are many root cause for it. Let's assume if the server goes down, then our data also lost. So in that scenario, a new technology WebRTC comes into picture. So we don't need any server to pass the data. Client 1 basically send the data to client 2 directly, and client 2 send the data to client 1 directly without any intermediate server. So we don't need server anymore for the WebRTC. So WebRTC comes into picture, in which we need to send the data from client 1 directly to the client 2. So this connection is basically comes under the UDP. So what's the UDP? So we have two types of network. So first is UDP. UDP is a user datagram protocol. It's a communication protocol that allows the devices and the application to send data over a network without establishing the connection before sending the data. And what is TCP? So TCP is a communication standard that allows the devices and application program to exchange messages over the network. So we have UDP and TCP. So if you're aware of the HTTPS basically created on the top of the TCP. TCP is reliable, acknowledgeable, stable, but UDP is fast. TCP is not slow, but not as fast as UDP. So if you, let us take an example, if you join a meeting inside the Meet or the Zoom call, and let's assume your connection goes down. So once your connection goes up again and you will be joined, so you will see, you will basically get the latest data, not waits other to join to you. So it gives the data as a latest mode. So we are using the UDP in that scenarios. UDP is really fast but not reliable as compared to TCP. But if we want to the things in the real time, we use the UDP. So these two are separately different thing. We can't compare like to each other. We basically use the protocols, network protocols based on our requirement. So let's assume if you play a game, your internet goes down, so other player can't wait to join again. Once you join, you will get the latest update on that game from where you need to start. So in that scenario, we need the UDP because we need the latest thing. So that's What is WebRTC? WebRTC is a connection between two clients, which uses the UDP and without using the intermediate server. So start WebRTC. I have basically divided WebRTC into two parts. First, GUM, and second is PC. So what is GUM is graphic. What is GUM? GUM is a user media, graphic user media. Inside the graphic user media, we have three things. First is we can send the camera stream, we can send the mic stream, as well as we can send the screen stream to the another client. So GUM means graphic user media. So what's data we need to send? This type of data we can send over the WebRTC. Second is PC. What is PC? PC is a peer connection. So there is a connection established between the client 1 and client 2, which is a peer connection. So if we talk about the peer connection, we will talk about the P2P connection. What is P2P connection? It means peer-to-peer connection. It means we establish a connection between the client 1 and client 2, which is bidirectional in flow. So the bidirectional flow between the two clients is called peer-to-peer connection, in which we will send some data from the C1 and some data from the C2. So C1 data, C2 will able to see that, and vice versa. So now what we have learned from this part, WebRTC. WebRTC is a web application technology in which we can send the streams, audio or video and screen, whatever we need, without requiring an intermediate server. So, and the connection is based on UDP, not the TCP. So let's jump into the another one. So there are some other technology we need to, like, what is the workflow to establish a connection and sending the stream. Right now we are on that point. We need two clients in which we need to set up a WebRTC connection. So let's jump into the flow diagram, like how one client is connected to another and then the connection flow between them. So we need basically two answers before sending the connection and other things. We need to know where are you and what you are sending. So these two questions basically solve all the things, like where are you and what you are sending. So these questions need to be clarified before sending anything between two clients, which we are telling like P2P connection. So let's start. This one is client 1, this is client 2. So we have a peer connection between these clients. So I am adding a dot. It means we need to add a connection between C1 and C2. We can't send any public IP directly to a client because there are multiple things in between the connection, like network, adding translation net, firewall, VPN. Because if any client uses these things, network protocols, then we can't basically tell anyone to our public IP address. In that scenario, we have stun server comes into picture. What is stun server? Stun server are basically as you can say, WebRTC stun server are free servers which are provided by the Google. There are some free servers available, but we can basically make as well if we want. So if we go to the WebRTC stun, so there are multiple stun servers which are freely available for us, we can use. So what's the role of that particular stun server comes into picture? So we can't basically tell anyone to our public IP address because it's maybe there might be chances that user use these terminology, like uses the firewall, VPN and other stuff. So VPN basically do hide our public IP address and send to a private IP address to anyone. So there is some differences between them. So we can use a stun server. So stun server basically get our IP address and send us a ICE candidate. So what does this mean? So C1 basically uses the stun server, like get me my public address. Stun server send client 1 to ICE. ICE is a interactive connectivity established, like stun server gives a ICE candidate so that client 1 has own IC candidate, client 2 has own IC candidate, and these two IC candidate can interact each other without disturbing from the VPN and firewall. So same, client 1 send uses the stun server, establish a connection, peer connection, and stun server basically return the client 1 to IC candidate, like your IC candidate is this one. Like, so this is the first step. Client need to use the stun server to get their IC candidate. IC candidate helps the clients to find where are you. So for first question, where are you? We can't send any public IP directly to any client. We can use stun server to get the IC candidate and send to that particular client, here is my IC candidate, you can reach out to me on that IC candidate. So we need to give these two answers to each client, and then the WebRTC connection peer connection will establish. So for first question, user can send IP, then stun will return the IC candidate. Then user for client 1 need to add their tracks to that particular connection. So client 1 created their start their peer connection because they have IC candidate. Then client 1 need to add the track from where we get the track GUM. So we discuss what is GUM, graphics user media, like screen, camera, audio, whatever we need to send, we need to add the track of that particular peer connection. So this is a peer connection started from client 1. Client 1 add their tracks, whatever they want to send. After track, they need to create the offer. What is offer? So offer is an object in which we have RTC session description. So it's a new term. As you can say, what you are sending, we need to send a object, like what type of object you are sending, and what's the protocol, like what's the codec of your track, what's the other things you are sending. So if you just see these type of, we need to send these two data, like what is type. So create offer, type is offer, and SDP is the SDP is the mode of data, like which type of data are you sending it. So we create an offer with these two type of data. Type will be the offer and SDP will be the which type of data you are sending the details. Okay, so client 1 create a connection, get the IC candidate from the stun server, add the track to that particular peer connection, create an offer with these two details. Type will be the offer. I am creating the offer. Client 1 say I am creating the type offer, and SDP details of that particular track. Now client 1 need to set the local description and the remote description. So what's the local description? Local description is the offer, like which type of data you are sending. So local description means local data. So local data will be the same type, which is offer, because we are creating an offer for another client. And remote description will be the answer of that particular client. So we will come what is answer. So let's assume right now the local description, local is offer for that client 1, and remote is null in that scenario because the connection is not established between these two clients yet. So what is happening? Client 1 get the IC candidate, add the tracks, create offer with two details, update their local description and wait. Now Client 1 is waiting like for joining the client 2. Now how client 2 basically get the details from the client 1? Now signaling server comes into picture. What is signaling server? Signaling server is something like which can basically start, or you can say client 2 reaches the client 1 and client 1 reaches the client 2, because in the world we can't find anyone without like intermediate thing. So we need to set up an intermediate server to initiate our WebRTC process, and then then client 1 directly interact with client 2. So we need to initiate, we need a server to initiate the process. Then signaling server comes into picture. We can set up this signaling server using the socket.io and some other services we have. So what is happening here? C1 created the peer connection, waiting for client 2. So C1 basically send signaling server offer, like I have data, type offer, SDP the details of the track, send the signaling, and signaling basically send this data to C2, client 2. This is the offer and this is the IC of client 1. After getting the detail from the C2, C2 will start using the same process, like uses the own server. He also need to get details of that particular IP. So he will send their IP address to Eastern server. Eastern server basically return the IC candidate details for C2, and C2 will send their detail to signaling. Before creating, so first C2 get their IC candidate, same steps, get the IC candidate from the Eastern, add their local tracks. So now he also want to connect the connection, peer connection. So C2 add their local tracks, and then C2 basically create an answer. He got the offer from C1, so C2 basically create an answer. Now what is answer? Answer is the same RTC session description with these properties. So type should be now answer. SDP is the detail of track of their local C2, like which type of data C2 is sending, so that C1 is aware like C2 will send this type of data, and C2 also aware I will get this type of data from C1. So C2 get the IC candidate from the Eastern, add their local track, same, create answer with two properties, type answer, SDP detail of track, set their local description to answer, and remote will be the offer because he get the offer from signaling server, and send the detail to signaling server, offer and IC of the C2. So he will send offer and IC, and then signaling server send back the data of C2 to C1. Now C1 got the details. Now C1 got the details for C2. C1 update their local remote, local description to remote, and now the connection will be successful. And the connection will be the UDP. Now, initially the connection is TCP because we are using the server which should be reliable, because we are connecting the peer connection between them. And once the peer connection is done, then the signaling server, no need for the signaling server. Client 1 directly interact with client 2. Client will send their data to client 2, and client 2 will send their data to client 1. So now we will go to both things. Where are you? both clients use the stun server to get their IC candidate, send the IC candidate to signal, and vice versa. And what are you sending in that? Client 1 create offer, like I am sending these data, so type is a offer, SDP the detail of the tracks, like I am sending these things. Same, client 2 basically create an answer, type will be the answer, and SDP I am sending these tracks, so that both clients are aware about both, like which type of track I will get. So just recap, client 1 uses the stun server to get the IC candidate, like I am basically standing on that IC candidate, so that any client can reach out to any client with the help of IC candidate. We can't send my IP address or public IP address directly to any client, because there are multiple things which block our public IP address. Once we get the ICE candidate, then client need to add their track, create an offer, update their local description, send the offer and IC to the signaling server. Signaling server will send the data to client 2. Client 2 need to get their IC candidate from the stun server, add their track, create answer, update their local and remote description, send the data, offer and IC to signal server, and then signal server will send these details to client 1, and then client 1 update their answer remote description. And once the client 1 update their answer remote description, then connection is established between these two. Now signal server role is now completed. Client 1 send their data to client 2 directly, and client 2 data is sent directly to client 1. So where are you? We are using the stun server. What are you sending? We basically create the offer, create the answer with these detail, so that both can basically get the proper tracks what they need, and then they can basically both send their broadcasting things. I hope you understand this concept between what is WebRTC, why we are using it, and how basically we can make a peer connection between two clients. After creating the peer connection, you can send anything like audio stream, video stream, and screen sharing. So please hit the like button, share with your friends, subscribe my channel. Thank you.